This is an AS Maths question on circles. Okay, part A. The circle C has equation x squared plus y squared minus 6x plus 10y plus 9 is equal to 0. And what we need to do is to find, in the first part of part A, the coordinates of the centre of the circle C, and the second part of part A, the radius of C. Now, whenever we want to find information about the centre and the radius of a circle, we need to have its equation written in the right form. And that form is like this: x minus a all squared plus y minus b all squared is equal to r squared, where AB is the centre and r is the radius. So we're going to go about writing this equation in that form. So the first thing I'm going to do is to rearrange it and put the x terms next to each other. So I've got x squared minus 6x, and then the y terms next to each other, y squared plus 10y, and then move the 9 across the other side, so I've got minus 9. Now the important bit is I need to complete the square on both parts here. So with the x terms, I want to complete the square. So I'll write that as x minus 3 all squared. You want half the coefficient of the x term. Now when I multiply this out, I'll get x squared minus 6x and then plus 9. I don't want that plus 9, so I'll take that 9 off, minus 9. So what I've got written down here is the same as what I've got underlined in red here. It's the same thing written a different way, in the way that I want for a circle. Complete the square for the y's as well, so that'll be y plus 5 all squared. Again, if I multiply this out, I'll get y squared plus 10y plus 25. I don't want 25, so I'll take that off. So minus 25. So what I'm underlining in blue here is the same as what I've got written here, and this is equal to negative 9. So let's move all of the numbers across. So now I'll have x minus 3 all squared plus y plus 5 all squared is equal to negative 9, and then add 9 to both sides, and then add 25 to both sides. So that's going to give me x minus 3 all squared plus y plus 5 all squared is equal to 25. So from that, very clearly, I can see the coordinates of the centre. That's going to be 3, negative 5. And I can also see the radius. That's going to be the square root of 25, because 25 is r squared, so r is 5. Right, part B. The line with equation y equals kx, where k is a constant, cuts C, that's the circle, at two distinct points. We need to find a range of values for k. Now here's a little sketch of what's going on. So this is my circle C and my line y equals kx. The line is cutting a circle at two distinct, that means different points. Now to work out what's going on here, I would need to solve the equation of the circle and the line simultaneously. And I know from this piece of information here that I'm going to get two solutions. Now, if I'm going to get two solutions from the quadratic that I will get from substituting in the line into the circle, then I know that the discriminant of that resulting quadratic is going to be greater than 0. Let me write that out. Okay, right, so this is here if you want to pause it and just have a read through so you fully understand what you need to do. So the first thing that I need to do, I want to solve the equation of the line and the circle simultaneously, which means taking the equation of the line and then substituting that into the equation of the circle. So the easiest thing to do is just to replace all of the y's in the equation of the circle with kx. So let's do that. So we'll have x squared plus y squared. So y is now going to be replaced with kx, so it's kx all squared minus 6x plus 10y, that's 10 times by kx, there's a substitution again, plus 9 is equal to 0. Okay, so let's expand the sort of brackets that we have here. So I'll have x squared plus k squared x squared minus 6x plus 10kx plus 9 is equal to 0. From here, what I'm going to do is to collect together all of the x squared terms and the x terms, because I want to know the values of a, b and c so I can substitute them into this discriminant equation. So x squared, what have I got for x squared? So I've got a 1x squared there and plus a k squared, lots of x squared. So let's write this as 1 plus k squared in brackets x squared. Okay, what else have we got? Well, these terms can be grouped together, the x terms, and in terms of x terms we have 10k and minus 6, lots of x, and then just the plus 9 at the end, equal to 0. Okay, so now I have my value of a, b and c. Let's put those into the discriminant equation and set that greater than 0. So for b we have 10k minus 6, so b squared will be 10k minus 6 all squared, minus 4 times by a, and that's going to be 1 plus k squared, times by c, which is going to be 9, and this needs to be greater than 0 for the circle and the line to cut each other in two places. Let's now expand the brackets and simplify where we can. So first of all, here if we expand those brackets, should be able to do it in our heads. So 10k times by 10k, 100k squared. Then I'm going to get minus 60, then minus 60 again. So I'll get minus 120k. That's from expanding the first bracket, and then the plus 36, minus 6 times by minus 6. We'll expand this bracket here. So we will have, let's do the 4 times the 9, which is 36, times by 1. So we've got minus 36, and then the minus 36 times by k squared. So minus 36 k squared needs to be greater than 0. So I can already see that the plus 36 and the minus 36 are going to cancel out. I can put together my 100k and my negative 36k squared. So let's do that. So 100k squared minus 36k squared leaves me with 64k squared minus 120k is greater than 0. Now I can divide both of those numbers by 8. You don't have to divide yet, but I just prefer to be working with smaller numbers. So I would get 8k squared minus 15k is greater than 0. Now what I did here to get these two values of 8 and negative 15, I just typed in the fraction 64 over 120, pressed equals, and got the calculator to simplify it for me. So you can do that just in case, if you're not 100% sure what it's going to simplify to, or you don't want to make any mistakes, whatever numbers they are in any type of question, just type the numbers in the fraction, press equals, and it will simplify the numbers, it will divide them down for you. Right, so from what we've got here, we want to find some critical values. So we're going to factorize this, or put k outside the bracket, and then we'll have 8k minus 15 is greater than 0. So we're going to need to draw some sort of sketch to help us see when this quadratic that we've got in terms of k is greater than 0. Right, so what solutions do I get from this? Well, or critical values, I should say. So one critical value that will make this equal to 0 is, let's just write down CV for critical value, is going to be when k is equal to 0. So I'll mark that on my sketch, 0 here. And then the other critical value that I'm going to get is going to be when 8k minus 15 is equal to 0. So when 8k minus 15 equals 0. So from that I will get 8k is equal to 15, and then I will get k is equal to 15 over 8. So I'll mark that here, and I'll mark it as 15/8. Okay, so I've got my two critical values. The quadratic I'll get in terms of k is going to be a u-shaped quadratic because the coefficient of the x squared is positive. Let's draw a u-shaped quadratic like this. I'm interested in when it's greater than 0, so that's going to be these points here above the k-axis. So let me just shade those in. So I want this bit here and this bit here. Now, because those two regions are separate, when I write my solution, I need to write my solution as two separate inequalities. Don't be tempted to write those inequalities as one single inequality. So I will have k is less than 0, and the other region is when k is greater than 15/8. And that will be my answer. Do be prepared for questions like this to give your answer in set notation. So make sure that you are confident in writing answers like this in set notation if needed.